We're on the 2012 PAT, Unit C, Environmental Chemistry, answering question 29. In this one, we're asked what is going to support the greatest diversity of organisms. So what's best for creatures to survive? Okay, we've got a couple different water samples. We have how much dissolved oxygen is in that water. So more dissolved oxygen, like in colder water, that there's more waves and more action happening. Either there's a pump or maybe you're in a fast flowing river. That's going to be better for living things. So like a 6 is good, 5.5, that's good. 2, not good. Okay, not very many creatures are going to be able to survive with that low of an amount of dissolved oxygen. Okay, then in terms of pH, we've got 7, 6, 5, and 4 here. So if we remember our pH scale, 7 is pure water, great for living things. 6 is great. 5 and 4, they start dying because it's probably had too much acid rain or some runoff from a factory. Okay, then phosphorus. This was our substance that's going to cause an algae bloom usually, often from fertilizers from people's lawns and golf courses or fields being washed into waterways like rivers and lakes or even the ocean. So high phosphorus concentration is usually not a good thing. Okay, so this one is going to be the best for the living things. So let's see what the question is asking. Okay, which samples would support the greatest diversity of organisms? So probably this one for sure. Okay, it has the neutral pH, lots of dissolved oxygen, and low phosphorus. Okay, and then we're going to need a second best. Okay, so this one, number 3, no way. Number 1, again, not the next best choice. Okay, the next best choice we're going to go with is number 4, because we have the next best amount of dissolved oxygen, the next most neutral pH, and the phosphorus isn't relevant here. So let's go with 2 and 4. Samples 2 and 4, that's C. 29. There's always lots of kinds of oil spills, but the Exxon Valdez one was pretty epic in a bad way. Catastrophe in 1989. So people used that quite a bit to study what happens in an oil spill, because we had one tanker that leaked in an almost pristine, non-polluted at all environment by Alaska. And so they were able to track the point of origin to how far that oil was able to spread out, how long it took, how far it went, and what the concentration was over time. So that's what this cute little picture demonstrates. So that's our relevance here. And the science concept has to do with the movement of oil through the water to different locations. Okay, so it's not mixing with the water. It doesn't mix. Oil and water don't mix, so it can't be dissolving. So while dissolving is spreading particles out, that's great, but it's not being mixed. Okay, deposited, no, that's has to do with the oil actually sinking to the bottom of something. Okay, so often when we're talking about deposition, we're talking about particles in the atmosphere, like smog, the particles of particulates, they're called, that are going to fall to the ground, or sand grains sometimes will be deposited on the ocean floor if they were all churned up before in the ocean. Degradation, again, the third time they've used that concept in this test, even though none of the times it was an answer, has to do with whether a material can be broken down, so degradation. So we're going to go back up to A with dispersion. So the oil is being spread out. Yeah. Okay, so we just needed to know which D word was the correct one. Last one here is numerical response. and it's asking us about the LD50 for chemical X. Okay, so that's the lethal dose 50. So if we have a chemical, how much of that chemical do we need to kill 50% of our population? So let's look at our graph here. We have deaths per 100 test subjects. Oh, good. That's 100. That's easily divided by 50. So 50% of 100 is 50. So we want to know what the dose is on this particular chemical. So at 50 deaths, we are going to draw a line across here and perfectly intersects nicely with our graph at 100. So we would write 100 milligrams per kilogram. And I'm going to check and see if there's any fancy conversions, like they needed to know. Sometimes they change the units, like grams per kilogram or something. Okay, but they're leaving it in milligrams per kilogram, so we're good. So we'd put 100 as our answer. And that's it for the environmental chemistry questions.